In this video, I will review the problems that were presented as examples in the reading summary so that you can check your work.
Example one, trying to get an idea of what the word or means as far as probabilities and counts and things of that nature goes. Um, we're basically being told that one of the cards is selected at random from that stack you see above there. Determine the following probabilities. The probability of getting a lion or an even number. Now, or means that one or the other can happen, or both. They don't both have to happen, just one or the other. So each one of these lion cards fits this category because they all have a lion on them. Each one of these is an even number, so these fit that as well. Notice that there are two cards that have a lion and an even number on it. It's being counted twice, but we're not going to really count it twice for our purposes. I mean, it meets both conditions, but I'm only going to count it once. So when I count these, I have 1, 2, 3, 4. You can see the counts coming through here. I have 11 cards out of 25 that I'm going to be able to do this. So it's an 11 out of 20, or 11 out of 20, I said chance, which is about 0.55. The probability of getting a yellow bird or a number less than 3. So again, there's the case where I have my two yellow birds. Numbers less than 3 are all these. Now again, I'm making sure not to count, the yellow bird here twice. And so counting these up, I have 8 or 9 out of the 20, and that's going to give me 0.45. A lion or a 3. So again, I'm going to have all these lions, or any card that has a 3 on it. And so when I count these all up, I have 8, and 8 out of 20 is 0.4. And the probability of a red bird or an even number, so I'm going to look at the red birds. Even numbers are all of these. And so when I count these, I have 10, and 10 out of the 20 is 0.5. Now, an AND problem's a little bit different. AND problems, I have to make sure that both are being the same. So, two of the cards are selected at random. Determine that both the following probabilities, assuming that there was no replacement. Round to 4 decimal places. So we want to show the probability that both cards show birds. So I have 5 cards out of 20 cards that show birds. There's a 5 out of 20 chance on the first draw, and there was no replacement. So assuming that on the first draw I got 5 out of 20, that means there's 4 bird cards left, and there's 19 cards still remaining. So that one's gone, say, and now I have 4 bird cards left, 19 remaining, so 4 out of 19, which gives me a 1 out of 19 probability, which is 0.0526. The probability that both cards show an even number. So again, here's all my even numbers situations. And so that's 8 out of 20. 8 even numbered cards out of 20 cards. And so the probability that the first one is drawn is an 8 out of 20. But without replacement, I'm going to have one of those even cards gone. There's going to be 7 even cards left, 19 cards left in total, which is 7 out of 19. Multiply those together. I get 14 out of 95 when it's simplified, which is 0.1474. Both cards have a frog and an odd number. So, I'm only counting the ones that have a frog and an odd number. This one has a frog, but doesn't have an odd number. This one has a frog, not an odd number. There's a lot of other ones with odd numbers, like this one. These all have odd numbers, but no frogs. Same thing here, same thing here. So I'm only counting these frogs with an odd number. Now, there's 3 of these cards out of the 20. And so the first one is going to be a 3 out of 20. without replacement, I'm going to have a two of these cards left and 19 cards overall left, which is a 2 out of 19 probability, which ends up being about 3 out of 190 when everything is simplified, which is about 0.0158. Probably that one card has a line and the other one does not. A little tricky here. I have 5 cards out of 20 that are lions. I have 15 that don't, and 20 cards total, of course. So when I pick the first one, well, notice how it says one card has a line and the other one does not. It's not saying that I pick them up in any particular order. That's the other tricky part about this. So there's two possibilities. I can either get a lion, then not a lion, or not a lion, then a lion. And so these are my two possible outcomes. And so I'm going to have a 5 out of 20. So say I'm going the first one, lion and then not lion, it's going to be times a 4 out of 19, or a 15 out of 19, because I have 15 cards without a lion, 19 left over. Plus, not a lion, so it's going to be a 15 out of 20 times a 5 out of 19. And it's being a 15 out of 38, which is 0.3947. Example 3. A sample of 75 people yielded the following information about their health insurance. 2 people who provided information for the table were selected at random without replacement. Determine the following probabilities. Round answers to 4 decimal places. So we know we have 75 people, and so the denominator is going to be 75, at least for the first person chosen. And so we're looking for the probability that neither have health insurance when we draw 2 people. And again, we're doing without replacement, 2 people. So 15 out of 75 would be in the first choice, and then 14 out of 74 on the second choice, which gives me a 7 out of 185 when it's simplified, which is 0.0378. The probability that both had a managed care plan. Well, that's going to be a 33 out of 75 for the first one. And now that I picked that first person, I'm going to have 32 of those people left, 74 in my total left. That's going to be 32 out of 74, which is a 176 out of 925, which is 0.1903. The next one, the probability of at least one having traditional insurance, kind of similar to some things we did before, but let's skip this one for now because it takes a little bit more specialized care with this. Let's have a look at some of the other ones, and then we'll come back to this one. The probability that the first chosen had traditional insurance and the second had a managed care plan. And so this one is going a specific order here. And so I'm going to let these represent managed care, traditional, and no insurance. And so this one's asking me to find the probability of the first one T and the second one being M. And so the first one being T, I'm going to have a 27 out of 75 chance. And now, technically that's going away. I have 26 of those left, and I have 74 in total left over. But the second one I'm picking is managed care plan. That's an M. And so that's going to be, 33 out of 74. And that's going to be 0.1605. On the next one, it says the probability the first chosen had a managed care plan, the second had traditional insurance. I don't know why that came up last there, but so here I'm going to have, again, the first one being M, the second one being T. Notice that I'm going to have 33 out of 75 on the first one, cross that out, of course, have 32 left, 74 left in total. Notice I have the exact same numerators being multiplied together, and it's the exact same denominator. So it's the same probability for this. So the order doesn't usually matter, but since I do have 2 different orders of outcomes that can produce the exact same result, I have to count both of them. And therefore, when I ask the question, the probability that one had a traditional insurance and the other had a managed care plan, and it's not naming any particular order, that's both of these cases combined. And so I have to add these two together, or basically double this probability here, and get about 0.3211. Now getting back to the third one, probably of at least one having traditional insurance. Again, at least one, or any of these at least, they're a little bit more complicated because, you're looking for the probabilities, like, well, if one or both, in this case, if there was like more in your sample, then it would be like 1, 2, 3, 4, whatever, how many there are. That can be much more complicated, especially when you're considering that you might have to consider orders in which they occur too, and account for that and things of that nature. And we're going to learn a couple of things that help us later about how to reduce that a little bit. But one of the easiest way to handle probability of at least one is realize it's the exact opposite of none. So the probability of at least one traditional, or 1t, is equal to 1 minus the probability that none are from group T, or both do not have it. So there's 48 who do not have traditional insurance, so 33 and 15. That's out of 75. So I'm choosing from, I'm going to say the probability of like getting these two groups. So the probability of getting the first person to not have traditional insurance is 48 out of 75. And then the second person is going to be 47 out of 74. So I'd multiply those together and do 1 minus that to get 549 out of 925, which is approximately 0.5935.
And that is the end of this video. If you have any further questions, please make sure to reach out and ask me about it. Until next time, have a good day.